Hi, I'm delighted to have you back to Sapima tutorial. Please, if it's your first time through my page, like my videos, share my content to your friends. Please don't forget to subscribe to my page. Thank you so much. We have inequalities on the board to consider. Inequalities in two variables involving graph. Before we solve the two questions we have here, let's consider the basic knowledge you need in order to plot a graph of linear inequality. The first, we have greater than, less than, greater than or equal to, less than or equal to. These two, we call them weak strict inequalities. Strict inequalities. Strict inequalities because the boundaries are not included. The values we are looking for are always higher than the boundaries. For instance, if x is greater than 2, that means the values of x must be strictly greater than 2. So the range of these values are 3, 4, 5, etc. We continue getting to infinity. Then the same thing happens with less than. If x is less than 2, that means I'm talking about numbers 1, 0, minus 1, minus 2, and so on. But when we talk about weak inequalities, greater than or less than, weak inequalities, boundaries are included. If I say that x is equal to or greater than 2, that means we're talking about numbers that begins from 2. I'll have 2, 3, 4. 2 is the boundary from the beginning. Then if I have x less than or equal to, let's say 4, I'm talking about all the numbers that are less than 4, but 4 also inclusive. That means I'll have 4, 3, 2, 1, going down, minus 1, in that order. So this one we call it strict. Those numbers must be bigger than the number in question, and these boundaries are included. Then the next thing we consider is plotting the lines of greater than or less than. To plot greater than or less than, we use dotted lines. Anytime you want to plot the line of this on the graph, it must be dotted. Then if it is this one, it is thick continuous line. The next thing we consider is which side of the line do we shed? Because inequality, you shed the side that defines the inequality given to you. Alright, so let's assume I have y greater than or equal to 0. It means that the value of y must be bigger than 0. So it could be 1, 2, 3, and others. Alright, so whenever you have that, then the point must be on the x-axis. Therefore, we shed the x-axis, the above the lines greater than, we are shading above. If I have x greater than or equal to 0, I will shed the y-axis, and it has to be the right-hand side of the y-axis. Again, if I have y less than or equal to 0, I will have to shade the x-axis also again. This is y greater than or equal to 0. Here is x greater than or equal to 0. Then the under here is y less than or equal to 0. Therefore, x less than or equal to 0, I will be shading the y-axis, but behind, because I have less than. I'm talking about the numbers that will move towards the left. Now, what if I have a line of the graph passing through the graph like this? Which side defines the inequality if I am given any of these? Greater than or equal to, less than or equal to. If I have greater than or equal to, I will shed above the line. Above the line. So here is above my line. I'll be shading here. But if I have less than, that means I will shed below the line. Below the line. Okay. No matter the shape the line is taking, if it is like this, here it becomes above. So this is for greater than. And under here is for less than. Please take note of this. Then if what I am plotting is less than or equal to, not rather less than or greater than, that means I will use dotted line to plot the lines of the graph. If I have less than, I will shed below. You see, here is below the line. If I have greater than, I will shed above the line. With this information, we are going to be handling this question now and represent it on the graph. Okay, to solve this question, solution. Let's take number 1 first, or equal to 12. I'll solve them individually, the same way we solve the graph of linear equation. That is how we solve inequality. So I'll prepare a table for all of them. Now y is less than or equal to 5. That means I have a value for y which is less than 5 and no value for x because x is not represented here. Therefore x is strictly 0. I'll prepare a table for this one. We are going to use the knowledge of x and y intercept. When x is 0, y always has a value. When y is 0, x has a value. We use this to get the values of x and y of this inequality. So I have x minus y equal to 1. First thing you do is to change it to equation. Alright, so let my x be equal to 0. If I put 0 for x, that means x is gone. Y, to get y, I will say divide both sides by -1, which will now give me y to be equal to -1. So I'll feed my table 1, 0 and -1. Then if my y is equal to 0, that means I'll substitute 0 for y. Y is gone. That means x is equal to 1. X is equal to 1. So I have 1 for x and 0 for y. We go over to the next table. Okay, then let's write it down. 4x plus 3y equal to 12. First thing, change it to equation. Alright, so when x is 0, if I put 0 here, 4 times 0 is 0, so x is gone. Divide both sides by the coefficients of y. If I divide here by 3, divide here by 3, that means my y will be equal to 4. I have 0 and 4. Then if y is equal to 0, if I put 0 here, 3 times 0 is 0, y is gone. Then I have 4x. If I divide both sides by 4, 4 divided 12 will give me 3. Therefore, my x is equal to 3. Put this on the table. Okay, so I have this as the information to draw the graph. We move straight into plotting the graph of the inequality. I will use 2 cm to represent 2 units. 2 cm to represent 2 units. Okay, I have my Cartesian plane. Let us start plotting. At this point, I have x to be 0, while y is 5. The origin is always the 0. Okay, so if x is 0, 5 will be somewhere in between 4 and 6. Alright, that is done. Okay, so I will have a horizontal line to pass through the point. Whenever you have one point on the Cartesian plane, if it's on the vertical line, then we have a horizontal line to pass through that point. If I have another line like this and the point, just a point on the x-axis, that means I have a vertical line passing through that point. Okay, so from the second table, but don't forget, after you have plotted your graph, write the inequality on that line. The second one, when I have 0 for x here, I have -1 for y. -1 should be somewhere in between 0 and -2. I'll make my asterisk here. Then when I have 1 for x, I have 0 for y. Find 0 first, the 0 for y and 1 for x, which will be somewhere here. It will be plotted on the x-axis. Okay, so I'll have a line to pass through the 2 points, extend it as much as possible to touch the other line produced. The third one, okay, this is x minus y less than 1. For the third one, I have 0 against 4. 0 for x, 4 for y to be on the y-axis. Then I have 3 for x, 0 for y. Locate 0 first, which is for y, and 3 for x, which is somewhere between 2 and 4. Then join the asterisk or the 2 points. Extend it as much as possible to cut the other 2 lines. Okay, so this is the graph of this inequality. For this is the third one, 4x plus 3y greater than or equal to 12. The next thing we do is to shed the region produced by the given inequalities. The three of them has their own side to be shaded, but we have to produce the region bounded, produced by the three of them, which we call the feasible region. The feasible region. Okay. So to produce that, we consider the inequalities. The first one, I have y less than or equal to 5. Remember, when you have less than and you have a horizontal line, you shade under the line. But I'm not going to be shading here because I'm looking for a region produced by the three of them, which will fall around inside here. Or let's produce and see. So for this one, it will be somewhere here. Somewhere here. Okay. Then let us get the second one, which is this. Before I plot it, consider your y. Y has a negative sign. If y has a negative sign, x minus y less than y, and you make y subject formula from here, I will have y minus y less than 1 minus x. To eliminate this negative sign, I will divide both sides by minus 1. And the law of inequalities, one of the rules, says that whenever you divide by a negative number, the sign will change from being less than to greater than, or from being greater than to less than. Since the sign has changed to greater than, I will not be considering the original sign given to me in the question, but the one that has changed to greater than. So I'll have minus 1 plus x. Okay, this has gone. Okay, so this will have y greater than. That means I'll be shading above because I have greater than. Right, so this is the side to be shaded. This is the side should be shaded. Okay. Then for the last one, y is positive, so no need making subject formula. We do subject formula when my y is negative sign. Okay, from here I have this to be greater than 12. Since it is this guy, greater than means above. We shade the above like this. Okay. Having shaded all of them, where do we have that produced a bounded region? It is inside here. So our feasible region is here. You now shade it well to indicate your feasible region. This is the area bounded by the three inequalities. Thank you very much for coming on board. In my next video, I will solve the second one, but you can use it as a practice before the video drops. Alright, do not forget to subscribe to my page and share my contents to your friends. Thanks a lot.